don't clear the table just yet. We've got another helping of food science for you. We've got some scientific advice on how to get the most bang out of your bubbly. Tastes good. Up next, we're poring over the science of bubbles. Here are some facts to whet your appetite. Lipstick and champagne, they clash chemically. Frosted beer mugs, a no-no for flavor. And if you want to keep that open champagne fizzy, corking is not the answer. What is the answer? Well, here to explain is Bubble Master Dr. Richard Zare. He is professor of chemistry at Stanford University in Palo Alto, California. Welcome back to Science Friday. Happy New Year.
Well, thank you, Ira. Same to you.
Thank you very much. Let's go through some of this bubbleology tips for us. Do you have any tips for getting the most flavor and fizz out of champagne?
Well, it turns out that as it warms up, you get more volatiles that come off when it evaporates. And that's, of course, very enjoyable because most of our taste comes from smell, not actually from inside our mouth.
So let it warm up a little bit before you drink that icy stuff.
That's right. This also actually applies to beer, Ira. Let me mention some things. Many people drink beer just from the bottle. And while I understand how quickly that is to take in the beer that way, because as I mentioned to you, smell is involved. You just don't get much smell when you put a bottle to your mouth. Much better is to drink beer from a glass. Mm-hmm. Now, what type of glass? Well, many bars serve frosted glasses. They think that's quite fancy and wonderful, but actually I think that's a bad idea, as does my friend Norman Metzger in Washington, D.C., who pointed this out to me. It turns out that if you cool liquids that contain gases, the liquids dissolve the gases better, and it is the gas coming off the liquid which is part of the aroma, which really makes, again, beer be so enjoyable to many of us. Now, I understand that on a very hot day, nothing like a really cold beer, but in terms of taste, sipping from a glass that's cool is really quite wonderful.
Now, I understand, as I said before, that as for lipstick will kill the bubbles?
Well, the bubbles are held together by this sort of membrane of various things that surround the carbon dioxide that's making the bubble. And when you add something like too much detergent, somebody doesn't really wash out the glass well, or some people even rub their nose and then put their finger down. And this kills bubbles. And the oils, any type of oil, including chapstick, Vaseline, etc., will actually cause the bubbles to burst. It really destroys the surface tension and makes it uneven, and the bubbles burst this way. So it's very interesting to see, and it's very obvious on New Year's Eve. Generally, women have less bubbles in their glass of champagne than men do, for the obvious reason that women generally wear lipstick. On the other hand, this thing I just told you doesn't always work, because just like you can have secondhand smoke, Ira, you can have secondhand lipstick. So try it out.
I'll tell you, what a pickup line for New Year's Eve. I'm doing a scientific survey of the lipstick around here, and I ask you a few questions about your lipstick and your champagne. There's an opening for you. All right, let's talk about having that open. But you've now opened our bottle of champagne. You want to save it a little bit for the morning after. What's the best way to save it? I know you have done experiments about the best way to keep the bubbles in a bottle of champagne fizzy till the next morning.
Well, actually, Hal McGee and he's the curious cook, who wrote a column for the New York Times for that subtitle, I think, looked into this. And the truth is that the best way to keep gas dissolved in your liquid is to keep the liquid cold. Anybody who's played around with water knows as you start to heat it up, it really drives the gases off. And hot water is much flatter, and so is any liquid, and it releases gas that way. So you really, to keep your champagne effervescent, you want to keep it cold. So returning it to the refrigerator or keeping it in an ice bucket's just the right thing to do.
You don't have to put the cork back in it or anything
You,
like
you actually do not. There's enough carbon dioxide in the champagne to go on for many days. We've seen that.
I'll
There's
bet
something
you,
else that's interesting that happens if you leave the champagne uncorked. Just like with wine, you get a change in its taste due to some oxidation from the air. And that actually can be quite pleasant, too.
I'll bet you have spent many hours verifying.
Oh, it requires it. All in the name of science, Ira.
Of course. But what about that trick of sticking a spoon down the neck of the champagne? Is that all just an old wives' tale?
Well, from what I can tell, the only effect the spoon has, like a silver spoon, is if it helps cool the bottle down when you put it back in the refrigerator. Otherwise, I don't think it works.
Now let's talk about the bubbles in your glass of champagne or your glass of wine, because there's a whole bunch of physics going on there, isn't there? Let me start with
a lot of chemistry too.
Of course, you're a chemist. You would be saying that.
Well, let's consider how the bubbles get there in the first place, or what goes on in champagne. I think it all starts with this Frenchman by the name of Dom Pérignon, who lived about 1639 to 1715, and developed this thing called the méthode champenoise, where you take some type of wine and you bottle it again with sugar and yeast to cause a second fermentation. And this yeast converts the sugar into carbon dioxide and ethanol, the alcohol we enjoy drinking. And you also, of course, have other things that are left over from this. You get a couple grams per liter of different other materials like glycerol and tartaric acid and lactic acid. And it turns out that champagne's actually acidic. It has a pH of about 3.
Wow.
But if you look at the amount of carbon dioxide that's in the champagne, it's immense. At sea level, the pressure of the air is 1 atmosphere. The amount of carbon dioxide in the bottle of champagne when you opened it is something like 7 atmospheres. It's loaded. It's super saturated. It wants to come out. And here's the problem. How do you get bubbles to come out? It's just one of the same questions about how do you get clouds to rain. You need some form of nucleation, something to happen. And now I need to tell you that most of champagne is actually just water. And water loves water. Water loves water so much that it crushes little bubbles. And you don't see bubbles ever form in the middle of a glass of champagne, the same way you don't see bubbles form when you boil a pot of water and you look at it. The bubbles do not form in the center of the liquid. Instead, they form on the walls, on the sides. Why? Because they need to hide and grow to a critical size. And they tend to actually form on various forms of, well, shall I call it dirt, fibers, dust, scratches in the glass, places to hide and build up to be a big enough bubble so it can escape and not be crushed by the water.
Let me just interrupt for a second and remind everybody, I'm talking with Dr. Richard Zare on Science Friday from NPR. So that's why you see them forming in lines. They may be lining up in a crack in the glass, or they're coming off the sides. And I guess you can revive a stale glass of beer by nucleating it somehow.
Well, one of the simplest ways, but I don't recommend it, of seeing this effect is to dump in a tablespoon of either sugar or salt into a carbonated beverage. You'll see a great deal of foam being formed.
Wow.
Sand will work, too. I don't recommend any of those 3.
Well, does that explain why in soft drinks like root beer, which has a lot of fizz inside of it, when you make a root beer float and you pour it on the ice cream, it just explodes with foam because the ice cream has all those little nooks and crannies in it?
Yes, and ice cubes, too. Let me talk about ice cubes for a moment.
Please.
Have you ever noticed that when you pour any carbonated beverage on ice cubes for the first time, lots of foam.
Right.
You drink it, then you say, I want a refill. The next time people pour on the ice, the same ice cubes, right?
Right.
Much less foam. It's not that the bottle has gone flat. It's that all the sharp spots on the ice, the asperities on the ice, have melted away. And without these little nooks and crannies, again, the carbon dioxide doesn't know how to escape. It wants to escape, It wants to go to 1 atmosphere. It just doesn't know how.
That would explain why I've heard about bartenders sprinkling some salt in your beer to make it foam up again.
It does.
Yeah.
Try it. It works in champagne and beer, but I don't think that for the purpose of taste, it's the thing to do.
Not at all. Now let's talk about one of. I once saw a video that you created about bubbles in a glass of beer that they don't always go up. The bubbles seem to be going down, and you tried this with what? And you
with Guinness beer.
Guinness. Famous for
that's
all
right.
those bubbles in there.
And it's at first quite a puzzle, and you wonder. People reported that the bubbles on the sides of Guinness, a glass of Guinness beer, were going down. How could bubbles be going down? Is it that they just had too much beer to drink? What's happening here?
Yeah.
What's actually happening is that everywhere it's bubbling, but the bubbles in the center of glass actually have less drag, less friction on them, and they rise more rapidly, more easily than the ones on the side. And the result is they set up a circulation of the liquid. And bubbles are very slowly moving in beer. In fact, if you'll notice, champagne has much more rapid moving bubbles than beer bubbles. And we could discuss why that is in a moment. But anyways, the result is that because of the liquid circulation, the bubbles go down initially.
Wow.
in a glass of Guinness or some of the other very highly carbonated beers.
Well, one last quick question for you, Dr. Zier. Why are some bubbles bigger than others, depending on the beverage? Is that what it is?
Oh, I wish I understood all this. Part of it has to do with the size of the crack or crevice that you have. And it's been a mystery to me as to what controls totally the size of the bubbles.
All right, well,
I don't know the answer to that.
Well,
one.
we hope you enjoy finding out.
More to learn.
Boy, always
I shall study this.
Please do that, and maybe next year we'll come back and talk to you again. Dick, have a happy New Year. Thanks for joining us.
And, I get no kick from champagne. Mere alcohol doesn't thrill me at all. So tell me, why should it be true, Ira, that I get a kick from you? Thanks so much.
Thank you very, very much. Dr. Richard Zier, who is, I guess he has a day job, but he likes to do most as being a bubbleologist. He's professor of chemistry at Stanford University in Palo Alto.